Hi everyone. Hope you're enjoying working with your team and have been in touch with your client and contacted your faculty advisor. And I'm looking forward to hearing how things go with that. Meanwhile, for this coming lecture tomorrow, we're going to talk about how to plan and manage a design project. A project is just a set of ordered activities that leads to some goal. There's a number of models for thinking about how engineering design is done that we've looked at, and they're basically like most projects. They have a beginning, a middle, and an end. A successful project relies on clear definition of what the goal is, what activities need to be accomplished to reach the goal, and what resources are available and when they'll be used. This is the statement of work. Project planning allows the project team to create a work breakdown structure of what needs to be done, in what order, what resources each activity needs, and who is responsible for each activity. For most projects, there's a lot of activities that have to take place, and so related activities are grouped together into phases, with each phase ending at a defined milestone before the next phase begins. For us, phase one is all about understanding where you're going, putting together a good plan to be able to execute the design. Phase two is about creating good concept designs. Phase three is about delivering the detailed design. The work breakdown structure gives details of each activity and any dependencies, such as in what order the activities need to be done, and whether an activity has to wait for some other activity or set of activities to be completed before it can start. The schedule puts the activities into order, respecting dependencies and resource allocation. Project resources include people, materials, energy, facilities, including shop space, and information technologies, services like manufacturing, shipping, accounting, and contracts, and money. In a small design project with no significant prototype development or testing, the resource allocation is mostly people's time. If one of your team members is responsible for doing both the CAD drawing package and writing up structural design calculations, then this person is a critical resource that has to divide their time between two activities. This will slow down the progress of the entire project when either of these activities is on the critical path. Now, there's a lot of ways to plan and schedule the project, with software packages such as Primavera, Liquid Planner, and MS Project being most popular. There are free packages available at all. You're welcome to use any of those, provided you can put together a project plan that shows the key activities, how they're sequenced, and be able to update them in a way that shows your progress toward completion. As well as a team, you should show that your time allocation is fairly distributed with as level a commitment of time as possible. You'll probably end up with a little bit of time near the end where you're working a bit harder, but you should not be pulling all-nighters. Small project management, it's just the art of running the project and dealing with changes that have to be made in the plan and schedule when reality sets in. This can be internal issues, such as a team member getting sick for a week, or external issues, such as the client asking for a change in the scope of work, or a team member having an unexpected obligation outside of the project. The project schedule should already take into account any known commitments, such as other coursework demands and non-negotiable family obligations. These should be put into schedules as resource constraints. If something unexpected comes up, then the team has to be able to address the change and reallocate resources or modify the scope to deal with the change. Also, the original plan is simply the team's best guess of how long each activity is going to take and what people will be a part of it. The plan will change as you proceed. And so, you're going to update the plan and the schedule regularly to reflect the improved understanding of what activities require. In this course, we will formally do that at the end of phase one and at the end of phase two, because there's not much point in updating the plan too often. It's just meant to help you to keep track. Now, before diving into a software package, it's usually worth taking some time as a group to think about what tasks are likely necessary, who's best suited to do particular tasks, and when tasks probably need to be done. Each team will do an activity tomorrow and through next week to create a rough project plan using simple post-it notes connected by time and resource dependencies. Once that's done, you'll submit that along with a software representation of that. Again, it could be using Liquid Planner or one of these other project planning and scheduling software packages, or it could be an add-on to Slack, such as Trello, or it could be even just an Excel spreadsheet. The more sophisticated a package you use will take more time to learn and may be more than you need for the amount of resource allocation tracking that this small project will require. Even though the plan will neither be complete nor completely accurate, it's still a useful tool. As they say, failing to plan is planning to fail. Failing is okay as long as you learn from it. We'll fail to make a perfect plan, we'll fail in most of our concept ideation at first, and we'll fail to get the detailed design right the first time. That's okay, because failure during design is necessary for success at the end. That's why we plan to be able to do a little bit of iteration and rework to be able to ensure that we learn from what we're doing, fail forward, and be successful. Now next week, I'll be away on a research trip with some students. The engineering librarian will talk with you about how to look up relevant material, about the design problem, previous solutions to the problem and their limitations, and codes and standards that may be applicable in the design, production, and use of the design solution. You'll, of course, be busy starting to prepare the Phase 1 report while you're continuing to develop your technical specifications with the client. And the elements of the Phase 1 report are described in the rubric that's posted on eClass. Next time, we'll discuss Phase 2, which is conceptual design, the most creative part of the design process.